Hello students, welcome to aimsindia online classes. This is chemistry session. In this, we are discussing about atomic structure chapter. In this session, we are going to see practice sheet 2 related to this chapter. In the earlier practice sheet, we have seen all single correct answer type questions. In this, we are going to see different kinds of questions which are related to level 2. Okay, first among them, we say about multi-correct answer type questions. Here, there will be four options as usual, but out of four options, there will be one or more than one correct answers for each question. So, read the question and options carefully and select all the correct answers. See the first one. Which one of the following is incorrect statement about proton? So here about proton, some statements are given. See which statements are correct and which are incorrect. See the first one. Proton is nucleus of hydrogen atom. Is it true? What does hydrogen atom contain? We know hydrogen atom contain one proton in the nucleus. Around that, one electron is revolving. So, what is the nucleus of hydrogen now? One proton. So, we can say the nucleus of hydrogen atom is nothing but proton. So, I can say this statement is true, isn't it? Proton is a nucleus of hydrogen atom. Next one, proton is a ionized hydrogen molecule. Is it true? No, because in the hydrogen molecule there are two hydrogen atoms, not single atom. So when this molecule is ionized, two protons will be remained, two H plus ions will be obtained, not one atom, one proton. So this is not correct according to proton. See the third one. Proton is ionized hydrogen atom. What is meant by ionized? Ionized means charged, nothing but electron lost. We know hydrogen can lose one electron. So when it is ionized, it will lose that electron and forms H plus ion. So H plus ion is nothing but single proton. So this also represents one proton because hydrogen has one electron, one proton. When hydrogen ionizes, it loses that electron so that the hydrogen ionized hydrogen atom will be remained with single electron, single proton. So proton is ionized hydrogen atom or the nucleus of hydrogen atom. These two are correct. See the fourth one what they have given. Proton is alpha particle. Is it true? No, because alpha particle is nothing but He2 plus ion. He2 plus ion is called alpha particle, or to say generally, the bunch, the group of two protons plus two neutrons. These all together, these four particles together called as one alpha particle. So He plus 2 ion contains two protons and two neutrons. It is not a single proton. So alpha particle means He plus 2 ion or group of two protons and two neutrons. But it is not a proton. So this also incorrect. Now what are the two correct options? Proton is nucleus of hydrogen atom and proton is a ionized hydrogen atom. These two are correct about proton. Now they're asking about incorrect statements, the remaining two, B and C. Okay. Next one. Which of the following statements are correct about alpha particle? Just now you have seen alpha particle is nothing but electrons removed helium atom or the nucleus of helium. So we know helium contains totally six particles, two protons and two neutrons in the nucleus, and two electrons are revolving around the nucleus in the first orbit. So if these two electrons are removed or if the helium is ionized, it will be remained with only two protons and two neutrons in the nucleus. That is alpha particle. Now they're asking about some statements which are correct about alpha particle. See, first one, these alpha particles carry plus 2 charge, isn't it? Yes, we have shown here. He plus 2 ions or alpha particles carry 2 units positive charge, because this alpha particle is a bunch of 2 protons and 2 neutrons. Neutrons are having no charge anyhow, but there are 2 protons with 1 unit each. So they are totally carrying 2 units positive charge. This is correct. Next one, their mass is 4 units or 4 AMU. Is it correct? Yes, it is also correct, because here there are 4 particles totally in the alpha particle. Each one carries 1 unit mass or 1 AMU mass. So proton mass is 1 AMU and neutron mass is also 1 AMU nearly, not accurately. So those are having nearly equal mass, that is equal to 1 AMU. Totally there are 4 particles. So the total mass is equal to 4 AMU. So it is also correct. Next one, they have no electrons, isn't it? Yes, an alpha particle is a group of 2 protons and 2 neutrons only. It is not having any electrons in it. So alpha particles are not having any electrons in them. That is also correct. Next one, they are He plus 2 ions. Yes, it is also correct. Electrons removed helium atoms or ionized helium atoms are called alpha particles. So this is also correct. Okay, what is the correct option now? These all are correct options about alpha particles. Okay, next one. Which of the following pairs are isotopes? What does it mean by isotope? Isotopes means the atoms or ions which are having same atomic numbers. Sorry, the atoms which are having same atomic number but different mass numbers are called as isotopes. So see here in the given options, which are having same number of protons or same atomic number with different mass numbers. Identify them, they will come under isotopes. See, first option, argon and calcium are given. Atomic number of argon is 18, atomic number of calcium is 20. So these two are having different atomic numbers. So they won't come under isotopic pair. Next one, carbon with atomic number 6, carbon with atomic number 6. So these two are having same atomic number, and if you observe they have different mass numbers. So the atoms with the same atomic number but different mass numbers are called as isotopes. So this is isotopic pair. Next here also see atomic numbers are same, mass numbers are different. So isotopic pair. Here also atomic number both are having same atomic number but mass numbers are different. It is having 16, it is having 18. So this is also isotopic pair. So the atoms with the same atomic number but different mass numbers are called as isotopes. Now carbon has isotopes here, chlorine isotopes are shown, oxygen isotopes are shown. These three are correct state. These three are correct pairs. But in the first one they have shown argon and calcium, which are not coming under isotopes, except the remaining three are correct. Okay, next one. Which of the following radiations is more energetic than microwaves? So, microwaves. Generally, microwaves will be in between radio waves and visible light. So, microwaves are having less energy than visible light, X-rays, UV radiation, and these all. And they have a little greater energy than radio waves. Okay. Now they're asking which of the following radiations are having greater energy than microwaves. The first three will come under that. Radio waves will be having less energy than microwaves. Okay. Now next question. The wavelength of an electromagnetic radiation is inversely proportional to. Wavelength is inversely proportional to. Let us see once the relations between these characteristics of electromagnetic radiation so that we can understand. We know E is equal to h nu. According to Planck's equation, we have relation E is equal to h nu. Okay. Then in the place of nu, we can write C by lambda also, because nu is equal to C by lambda, we know. Okay. Now this also can be written as H into C into 1 by lambda, isn't it? We know 1 by lambda is nothing but a wave number. So we can write now H C nu bar. These are the relations. Now they're asking wavelength is related with the options given here. See, wavelength and velocity of light. How do they relate? Here if you take E is equal to hc by lambda. If you bring lambda this side, lambda and c both are in the numerator, so it will be directly proportional to velocity of light. So wavelength is directly proportional to velocity, so it won't come under that, because they're asking which are inversely proportional to wavelength. So velocity is directly proportional here according to these equations. So that is incorrect. Next one, wave number. How wavelength and wave number are related? Inversely proportional one to another. Because we have formula lambda is equal to 1 by nu bar, or nu bar is equal to 1 by lambda. So either of these two will be correct. Now what do we get from these two? Wavelength and wave number are inversely proportional one to another. This is also correct. And if you see from this equation, E is equal to hc by lambda. So energy and wavelength are inversely proportional one to another. So energy is also inversely proportional to wavelength. What about frequency? Frequency also, because nu is equal to, right, c by lambda. So what is the relation between these two from this equation? Nu is inversely proportional to wavelength. So wavelength is inversely proportional to frequency, energy and wave number. But it is directly proportional to velocity. It won't come under. Except this, remaining three are inversely proportional to wavelength. This is correct. So BCD is correct answer now. Now, next one. Bohr's theory is not applicable to. Actually, it is one of the major drawbacks in the limitation in the Bohr's theory. Bohr's theory is limited or applicable only for single electron species like hydrogen and hydrogen-like species, which are having only single electron. For only those, Bohr's theory is applicable. Those which are having either greater or less number of electrons than one, for those species, Bohr's theory is not applicable. Now see here, which are having a single electron, which are having other than one electron. For those which are having other than one electron in them, for those Bohr's theory is not applicable. First one is see helium. How many electrons will be in the helium atom? We know there are two electrons. So as there are two electrons, Bohr's theory is not applicable to it. What about Li plus 2? Lithium atomic number is 3. As it is shown here, plus 2 charge. It means it lost 2 electrons. So there are 3 electrons. Out of 3, 1 and 2 are lost. How many will be remain? Only 1 electron. So it comes under now single electron species, to which Bohr's theory is fairly applicable. So for this it is applicable. What about He plus 2 ion? We know helium has 2 electrons. He2 plus means it lost 2 electrons. So it has 0 electrons now. As there are no electrons, Bohr's theory is not applicable to this also. See the last one, H plus. We know hydrogen has 1 electron. H plus means it lost its electron. Now there will be 0 electrons in this also. So Bohr's theory is not applicable for these two. Oh, only for Li plus 2 Bohr's theory is applicable among these all. For the remaining all, it is not applicable. Okay, next. Which of the following elements have valency 2? So, valency 2, the combining capacity 2. What is valency? The number of electrons gained or lost or shared by an element to become stable is called its combining capacity or valency. See, out of these elements, which one is having valency 2? We know oxygen. atomic number 8. If you write its configuration, it becomes 2 comma 6. Now, to become stable, how many electrons are needed for oxygen? 2 more electrons. So it will gain 2 electrons and becomes stable. So its valence is 2. What about magnesium? Its atomic number is 12 and its configuration will be 2 comma 8 comma 2. So it has 2 electrons in its valence shell. So to become stable, it will lose those 2 electrons and becomes like a neon's configuration, so that it can become stable. Now, what is the valency of magnesium here? As it gained 2 electrons, it lost 2 electrons, its valence is 2. What about sulfur? Atomic number of sulfur is 16. So its configuration is 2 comma 8 comma 6. Now it has 6 electrons in its valence shell, just like oxygen. So to become stable, even sulfur also will gain 2 more electrons and hence its valence is 2. What about beryllium? If we say the atomic number of beryllium is 4, so its configuration is 2 comma 2. Now if you observe, it has 2 electrons in its valence shell. So to become stable, it can lose these 2 electrons and hence its valence is also 2. Actually, beryllium shares 2 electrons to form 2 covalent two bonds. So its valency is 2. Now, finally, if you observe, for these all elements, valency is being 2. That might be either by losing electrons or by sharing electrons or by gaining electrons also. But anyhow, the valency is being 2 for these all elements. Next, comprehension paragraph type questions. First, let us see paragraph given based on this concept. So the frequency, velocity of light and the wavelength of electromagnetic radiation are related one to another. Yes, the other commonly used quantity, especially in spectroscopy, is the wave number. So these are four: frequency, velocity of light, wavelength, and wave number. These all are interrelated one to another. Now, based upon these relations, here let us see some questions. First one, if you say, which of the following relations are correct? Some relations are given based upon these characteristics of electromagnetic radiations. Now, see which is correct among these. See the first one, frequency into wavelength is equal to velocity of light. Is it correct? Actually, we have nu is equal to c by lambda. Frequency is equal to velocity of light by wavelength. So if you bring the wavelength to other side by cross multiplication, so we get frequency into wavelength is equal to velocity of light. The same statement is given here. So it is correct, isn't it? Next one. Energy is equal to Planck's constant into frequency. Yes, it is direct equation we can say. According to Planck's equation, E is equal to h nu. They have given directly. So that is also correct statement. See the third one. Frequency is equal to velocity of light into wave number. Let us see this also derivation. We have nu is equal to c by lambda, isn't it? So if you bring nu is equal to c into 1 by lambda, we know 1 by lambda is nothing but wave number. So in the place of 1 by lambda we get nu bar. So nu is equal to c into nu bar. That is, frequency is equal to velocity of light into wave number. So this is also correct. They're asking which relations are correct. Which are correct now here? These three are all correct. Okay, next one. The wavelength of a radiation is 97,540 centimeters. Calculate its frequency. So they have given wavelength. Wavelength lambda is equal to 97540 centimeters. It is given. And they're asking to calculate frequency. So what relation we are having here? Nu is equal to c by lambda. We know c is the velocity of light. So if we substitute these two values, velocity of light is 3 into 10 to the power of centimeters per second, and lambda value already it is given centimeters itself. So if we substitute these values and we calculate, we get this. We change the decimals, we get it as 3.07 into 10 to the power of 5 second inverse. It is a frequency, where it is the first option. Okay, now next question. The light of any electromagnetic radiation travels in vacuum or air with a speed of. So what is the speed of any kind of electromagnetic radiation? All the electromagnetic radiations travel with velocity of light. That is equal to 3 into 10 to the power of 8 meters per second, or 3 into 10 to the 10 to the power of 10 centimeters per second. Out of this one, it is given here. See, that is 3 into 10 or 8 meters per second is given. That's correct. Next one. See, try to match these characteristics of electromagnetic radiation and its units. What are the units of frequency? Frequency units are second inverse. What are the units of wavelength? Here we have to remember one more point. Here also we may get more than one correct matching for any character. So observe them carefully. So frequency units are second inverse, and it is also inversely proportional to wavelength, isn't it? So this also you have to observe. Next one, wavelength. Wavelength units are centimeters. Next one, wave number. Wave number is reciprocal of wavelength. That means it is inversely proportional to wavelength, and its units are centimeter inverse. These two will come for that. Next one, velocity of light. Velocity of light units are centimeters per second. Okay. See, once the correct matching is the way we get frequency, second inverse and inversely proportional to wavelength. Wavelength centimeters, wave number centimeter inverse, and reciprocal of wavelength. Next, velocity of light centimeters per second. So this is the correct matching. Okay, next, integer type questions. The valency of sodium is. What is the valency of sodium? We know atomic number of sodium is 11. Its configuration is 2, 8, 1. Now, as it has only one electron in the outermost shell, it will be ready to lose one electron, and hence it becomes stable. So its valence is 1. Next question. Number of electrons present in M shell of magnesium atom. M shell. What is the number of this shell? M shell. KLM. Means it is a third shell. We know the atomic number of magnesium is 12. And its configuration will be 2, 8, 2. So how many electrons in third shell now for this magnesium? There are 2 electrons. Okay. Next. Analytical approach type questions. Rutherford's alpha ray scattering experiment shown that. So what are the points shown in the Rutherford's alpha ray scattering experiment? First one is electrons have negative charge. Is it correct? Of course, electrons are having negative charge, but it is not shown or proved in the alpha ray scattering experiment. So this is not correct. Next one, the mass and positive charge of the atom is concentrated in the nucleus. Yes, it was proved in the Rutherford's scattering experiment because very few of them being deviated and most of the particles are scattered, or most of the particles are passed through the alpha gold foil. So this is correct. Mass of the atom and positive charge of the atom is totally concentrated in the nucleus. The nucleus term was first time used by Rutherford only. This is correct statement. Third one, neutron exists in the nucleus. Actually, we have to remember one thing here. The concept of neutron or the fundamental particle neutron was not at all discovered at the time of Rutherford's theory. It was found in the 19th and after the Bohr's theory actually. So till then they didn't come to know about the neutrons. They were considering that only electrons and protons are there in the atoms. So there is no concept of neutrons in the Rutherford's theory at all. Next one, most of the space in the atom is empty. Yes, it is also one of the points shown in the Rutherford's alpha ray scattering experiment because most of the alpha particles are passing through the gold foil directly without any deviation. So these two are the correct observations from the Rutherford's theory. What are those two? Second and fourth. It is correct answer. Okay, next one. Atomic models have been improved over the years. Arrange the following atomic models in the order of their canonical order. So here they have given some models or atomic models names. So which one is given first and next which one given, so which one is given last among these is find out and arrange them in the order. Which of these is given first one? Yes, Thomson's atomic model was the first among these all. And next to that, Rutherford's atomic model. And finally, Bohr's atomic model among these three. So Thomson's, Rutherford's, Bohr's. What is that order? 2, 1, 3. Where is it? Yes, here. It is correct. Next, the ion of an element has 3 positive charges. Mass number of the atom is 27, and the atomic number of neutrons is 14. What is the number of electrons in the atom? See, they have given the positive charge present on the ion, and its mass number is given, and even number of neutrons are also mentioned. Now we have to calculate the number of electrons present in that ion. We have to find out. So let us see that mass number is given as 27 and number of neutrons is given as 14, so that we can find out number of protons or atomic number, because number of protons is equal to atomic number. What is the formula to calculate atomic number? We know mass number is equal to number of protons plus neutrons. So if you write atomic number is equal to mass number minus number of neutrons, it gives atomic number. So we get it as 13. So atomic number of this element is 13. It means it will be having 13 electrons in its neutral state, because in the neutral state atomic number is equal to either proton number and even to electron number also. So it will be having 13 electrons in its neutral state, but they shown here it has a 3 units positive charge, means it will last 3 electrons. So originally in the neutral form it will be having 13 electrons, but it lasts 3 electrons. So there will be totally how many electrons will be now? 10 electrons. The number of electrons in the ion with 3 units positive charge is 10. So that ion will be having 10 electrons in it. Got it? Next. Identify the Mg plus 2 ion from the figures. N and P represent the number of protons, number of neutrons and protons respectively. So here they mentioned some diagrams which is representing magnesium plus 2 ion. We know magnesium means it will be having 12 electrons. Mg plus 2 ion means it lost 2 electrons, so it will be having 10 electrons. See which one is having 12 protons, because atomic number of magnesium is 12. So in the nucleus it should have 12 protons, and in the shells it should contain 10 electrons. Which one is that? Yes, here. This is representing 10 electrons in the two shells and 12 protons and 12 neutrons in the nucleus. So this is correct representation for Mg plus 2. Okay? Yes, because Mg plus 2 has 10 electrons, 12 protons and 12 neutrons. This is correct. Next, statement type questions. So the first statement, a neutral atom has equal number of electrons and protons. Is it true? Yes, it is true. A neutral atom will be having equal number of protons and neutrons. That is why it is being neutral actually. This is correct. Statement 2, a neutral atom has equal number of protons and neutrons. Is it correct? Of course it might be, but we cannot say for all the atoms. Many atoms, they do not have same number of protons and neutrons. It is not always true. So it is incorrect statement. So a neutral atom may or may not have equal number of protons and neutrons. So this might be incorrect. So we get C. Statement 1 is correct, statement 2 is incorrect. Next question. Cathode rays travel in straight line in the absence of electric and magnetic fields. Yes, cathode rays travel in straight lines. In the brains of electric field and magnetic field, they will be deflected or deviated from their path. But in the absence of these two fields, cathode rays travel in straight lines. This statement is correct. Next, cathode rays start from cathode side and move towards anode side. Yes, it is also correct. That is why only actually the name cathode rays is given for these particles. The particles moving from cathode side to anode side in the discharge tube were called cathode rays. Later on, we are calling them as electrons, but they were called cathode rays because of this reason. They move from cathode side to anode side. So this statement is also true. What will be correct answer? A. Okay, that's about cathode rays. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website www.aimstoday.in for latest updates and recorded videos. Thank you.